With our oceans, we've explored about 5%, and most of that is to scuba depths. So that leaves 95% of our ocean unexplored. So in other words, we know more about Pluto than we do about our ocean. Our ocean is changing rapidly, and it's a combination of reasons. There's climate change, pollution, sewage outfalls that are dumping into the oceans. We're seeing a lot of changes in a relatively short time that are unprecedented. So these are changes that we need to understand now to avert them in the future. I think the greatest needs in ocean conservation are really basing the management, the policy, on sound foundation of science. Mare was created to get the unknown of the deep water data. We go down and get the foundational information, and then we bring that to results, figuring out what it means, looking at our fishing laws, looking at our stewardship, our pollution, all the factors, including climate, that are affecting the oceans, and parsing out what's working and what's not. If we have in place a law that's working, that's fantastic. Let's trumpet that success. But if it's not working, let's change that law to something better.
Mare works in between conservation and science. We collect unbiased information, and we work with other conservation groups and scientists and academic institutions to develop the technologies we need to gather the information and then analyze that information so that it can be used effectively.
What we're talking about is sustainable fishing for future generations. So in order to do that, we need to take care of the resource, which means we need to understand it. In order to understand it, we need to dive down and get that information.
This is the business end of the remotely operated vehicle. This is where we have all of our cameras and sensors and lights. So for example, the pilot uses this camera down here for flying the ROV. In addition, we have a vertical camera and a digital still camera. These are both pointed down. All of the cameras have lasers on them that are spread 10 centimeters apart. So any fish or invertebrate that we tag or hit with those lasers, then we can scale it. We know exactly how big it is. And these are acoustic tracking beacons. They say, here I am, and we triangulate the ROV's location to the ship position, and we know exactly where every frame of video and where every digital still photograph is taken. And that we put into the database.
We are in areas that no one else is. And every time we go under the water, we see something new, we find something new, we observe something that's never been seen before. And if we weren't there, those stories and that information wouldn't be told.
The reason this work is important now is that we finally have the tools and technology to go down and do it this way. Going down and looking at fish in their native habitat, where they tend to live. We now are armed with knowledge, and we are really evening or balancing the playing field. We've gotten really good at catching fish. Now what we need to do better is steward those fish.
This is a critical time in terms of making a difference. This is our moment.
As I learned from my father, these places, you can't just save them once, they continually need to be saved. And so this is going to be an ongoing effort for our species and our oceans forever. We can't fail at this. We really have no choice. If our oceans die, we die. There's a lot of work to be done. So if we were better known, we would be better funded, and we'd be able to take on more of this work. We've steadily grown over the years, but it's incremental, and the problems are really monumental.